Welcome back to the deep dive. Today's going to be a heavy one. Usually we grab a book, maybe a couple of articles, when we try to, wrap our heads around a single concept.
We drill down, find one specific thread, and pull on it.
Exactly. We drill down, but
Yeah.
find the nugget and we get out. But today, we're doing something different. We're trying to build a machine.
A biological machine specifically, and a fairly malfunctioning one based on the data we're looking at.
Right, and not just any machine. We're looking at the human body, but through the lens of a stack of research that is, frankly, intimidating.
Hmm.
I'm looking at the table here. We've got a scientific statement from the American Heart Association. That just came out October 2025.
A huge one. Really a paradigm shift for them.
Then we have a study from Science Magazine, one of the most prestigious journals in the world, from April 2025. We have dense reviews on epigenetics, the microbiome. Frankly, it looks like the syllabus for a PhD program.
It definitely felt like a lot of homework preparing for this, but necessary homework, I think.
It was a massive amount of homework. But here is the hook. Here is why I think this specific combination of papers matters to everyone listening right now. You know that moment. Maybe you hit 35, maybe 40. You haven't really changed your diet. You haven't quit the gym. You're doing the same things you did at 25. But suddenly the waistline just moves.
The dreaded shift, the redistribution of assets, so to speak.
The spread. And the old tricks, they just don't work anymore. You cut calories, you feel miserable, you lose 2 pounds, and they come back next week with interest.
With a vengeance, yeah. It feels like your body has turned against you.
It feels personal.
It feels like a betrayal. You think, I'm holding up my end of the bargain. Why isn't my body holding up its end?
Exactly that. And for years, the advice has been painfully simple, right? Eat less, move more.
It's thermodynamics.
It's thermodynamics. If you aren't losing weight, you're just failing the math. You're lying about what you ate. But when you read these papers, these specific papers from 2025 and 2026, you realize the math isn't just hard.
The map is broken.
Or maybe we're just using the wrong calculator.
Well, the map assumes a closed system. It assumes a simple furnace where you throw in coal and you get heat. And what these sources show when you layer them on top of each other is that the body isn't a furnace at all.
It's what? An ecosystem.
It's an ecosystem, a vastly complex one. And it's an ecosystem that is currently under siege from about 4 different directions at once.
That is the mission today. We're going to connect dots that usually stay in different departments of the hospital.
Yeah.
We're talking about circadian rhythms, your body clocks.
Yep.
We're talking about the gut microbiome, the trillions of bacteria living inside you.
The inner garden.
Then epigenetics, which is the mind-blowing idea of how the environment actually changes your genes. And finally, the actual cellular mechanics of aging.
The nuts and bolts of getting older.
We're going to explain why the body fights you on weight loss and, more importantly, how you might be able to negotiate a truce.
And this is so crucial because medicine is often siloed. The cardiologist looks at the heart, the gastroenterologist looks at the gut, the geneticist is focused on the DNA.
And none of them are talking to each other.
Right. But the body doesn't work in silos. It's a systemic, interconnected web. If you pull a thread in the gut, the brain feels it. If you mess with your sleep, your fat cells notice.
And when you read these papers together, a picture emerges that is honestly kind of shocking. It explains why the calories in, calories out model feels so broken for so many people.
It's not that calories don't matter. Of course they do.
Oh, no. Right.
But the context of those calories, when you eat them, what form they're in, how they interact with your gut bugs, that seems to matter so much more than we ever thought.
And this all leads to a shift in thinking, which you mentioned to me before we started, moving away from homeostasis.
Yes. The conversation is shifting from homeostasis, which means balance, to something called allostasis.
Allostasis.
Which is a concept we are going to spend some real time on because it changes everything about how we view weight and health.
Okay, don't give away the ending yet. We're going to get to allostasis. But I want to start with the clock. Because the American Heart Association dropped this statement in October 2025. It basically says, if you aren't looking at when you eat and sleep, you're missing half the picture.
It's a massive paradigm shift. For decades, heart health was about cholesterol and salt.
Yep.
Blood pressure, maybe smoking.
The big, obvious things.
The big ones. Now, the AHA is formally recognizing circadian health as a pillar of cardiometabolic function. That's a huge deal.
So let's unpack this. We all know we have a biological clock. We get sleepy at night. We wake up in the morning.
Right.
But this source goes way deeper than just get 8 hours. It talks about molecular clocks. In our cells.
In every single cell. It's not just about sleep. It's about the synchronization of the entire body. You have a master clock in your brain, specifically in a part of the hypothalamus called the suprachiasmatic nucleus.
The SCN.
The SCN.
Sounds like a secret government agency.
It acts like one. It's mission control for your entire body's timing. And its primary signal, its main source of information, is light.
Just light.
Light hits the retina, specifically these special non-image forming cells, and a signal travels straight to the SCN. That signal tells the body, it's daytime, let's go. It synchronizes the entire system.
But here's where the report gets technical, and I want to slow down here. It mentions specific genes, CLOCK and BMAL1. What are these, and what are they doing?
Okay, so this is the beautiful part. Inside the SCN neurons, and actually inside almost every cell in your body, you have this transcriptional feedback loop. It's a tiny molecular timer.
An hourglass in every cell.
That's a perfect way to think of it. The genes, CLOCK and BMA1, turn on, and they act like factory managers. They promote the production of certain proteins. The main ones are called period and cryptochrome.
Period and cryptochrome. Okay.
So throughout the day, these proteins build up in the cell's main compartment, the cytoplasm. They're just accumulating hour by hour.
The sand is filling up the bottom of the hourglass?
Exactly. And once they reach a certain threshold, a critical mass, they actually perform a U-turn. They go back into the nucleus of the cell and shut off the CLOCK and BMAL1 genes.
Wait, they turn off their own faucet.
They turn off their own faucet. It's a negative feedback loop. Then the proteins degrade overnight, the inhibition stops, and the whole cycle starts again the next morning when light hits your eyes. And this entire process takes almost exactly 24 hours.
That is wild. So every single cell in my liver, my heart, my muscles has a little hourglass inside it that flips over every 24 hours.
Yes, and the SCN in your brain is the conductor, the maestro, ensuring all those billions of hourglasses flip at more or less the same time.
But the report says that our organs, our liver, our pancreas, they have their own clocks. These are peripheral clocks, right?
Right. They have the same molecular machinery, but they take their cues from the master clock, the SCN. Ideally, the conductor in the brain and the musicians in the organs are playing the same song at the same tempo.
But modern life, I'm guessing, desynchronizes them.
It throws a wrench in the whole orchestra. And this leads to a concept the AHA spends a lot of time on: social jet lag.
I love this term because it perfectly describes my life.
Yeah.
But define it for us strictly from the text.
That's such a great term. Social jet lag isn't flying to Tokyo. It's the difference, the discrepancy between your sleep schedule on your work days and your free days.
Okay, so give me an example.
If you wake up at 6 a.m. Monday through Friday for your job, but on Saturday and Sunday you sleep in until 10 a.m.
As is my constitutional right.
As is your right. But your body experiences that 4-hour shift as if you've flown across 4 time zones. You're basically flying from the East Coast to the West Coast every single weekend and then flying back Sunday night.
And the body hates that.
It loathes it. Because remember those molecular hourglasses? They rely on consistency, they crave routine. When you shift your wake time by 4 hours, you are confusing the gene expression in every organ.
So it's not just feeling tired on Monday morning.
It's so much more than that. The AHA statement is very clear. This irregularity, this social jet lag, is strongly and independently linked to obesity, metabolic syndrome, and type 2 diabetes. Your metabolic machinery is profoundly confused.
How so?
Well, your liver's preparing to release digestive enzymes at one time, but you're still asleep. Your pancreas is getting ready to manage insulin, but you haven't eaten yet. It's chaos.
Speaking of eating, this was the part of the report that made me put down my late-night snack for good.
Yeah.
Meal timing. They found a specific cutoff time for breakfast that correlates with diabetes risk.
Before 8:00 a.m.?
8:00. That seems incredibly precise. Why 8:00? Why not 8:30 9:00?
It's about where your body is on the curve of insulin sensitivity. The data they cite shows that eating breakfast before 8:00 a.m. is associated with a significantly lower risk of developing type 2 diabetes compared to eating after 9:00 a.m.
And the reason is insulin sensitivity.
The reason goes back to those peripheral clocks in your pancreas and muscles. Your insulin sensitivity is naturally at its peak in the morning.
Meaning my body is just better at handling sugar in the morning.
Much, much better. Your pancreas is primed to release insulin efficiently. Your muscle cells are wide open, ready to uptake glucose for energy. As the day goes on, that efficiency drops off a cliff.
So it's the body's way of saying the honeying gathering is done for the day, prepare for rest and repair.
Precisely. So if I eat a bagel at 8 a.m. versus that exact same bagel at 10:00 p.m., my body treats it differently.
Radically differently. The AHA report describes late-night eating as a powerful misalignment signal.
Yeah.
You're putting fuel into the engine when the engine is trying to go into maintenance mode.
What happens then?
The liver and pancreas clocks get totally disrupted. The food sits in your system longer. Your blood sugar stays elevated for a much longer period. And that excess glucose is far more likely to be shuttled into storage as fat.
It's like trying to do major construction work on a highway during rush hour. You're just going to cause a massive pileup.
Perfect analogy. And then there's light. This was also shocking. The source notes that even low levels of artificial light at night, we're not talking stadium floodlights, we're talking about a TV in the corner,
Or light coming from under the door.
even that increases cardiovascular risk.
Yeah.
This is the light hygiene concept. We all know blue light from our phones keeps us awake, but does it actually make us fat?
Indirectly, yes. The mechanism is fascinating. Blue light directly suppresses melatonin, which is the darkness hormone that helps you sleep. But it also directly confuses that SCN master clock. It tells the brain it's still noon, while your liver clock is screaming it's midnight because you haven't eaten in 4 hours. That chaos, that internal disagreement between your clocks, causes a stress response. It causes inflammation. And as we will see in a minute, inflammation is the root of almost all the evil here.
So step one in our deep dive is that timing is everything. It's not just the fuel. It's when you put the fuel in. But there was one glimmer of hope in the AHA report for those of us who maybe aren't natural morning people. The secondary synchronizer.
Exercise. This is really interesting. While light is the primary clock setter, the Zeitgeber, as they say.
The time giver.
Right. Exercise is the secondary one. If you are struggling with your rhythm, if you have that social jet lag, the research shows morning or afternoon workouts can actually advance your clock.
It effectively winds the watch a bit faster.
It does. It helps you wake up earlier and feel sleepy earlier. It sends a powerful signal to the clocks in your skeletal muscle, telling them, hey, we are active, align with the day.
But there's a catch, right? Evening exercise.
A huge catch. Evening exercise does the opposite. It delays the clock.
So if you're hitting the gym at 9:00 p.m., you're telling your body to stay awake longer, to push everything back.
Precisely. You're pushing your rhythm back, which can actually exacerbate that social jet lag we talked about. You're basically revving the engine right before you want to park the car for the night.
Okay, so our body's clock is clearly fragile and easily broken by modern life. That's a huge piece of the puzzle. But now let's move from the clock to the engine itself. Or maybe the ecosystem living inside the engine?
The gut microbiome, the second major battlefront.
We have this review from Metabol Open and another from PMC, both hot off the press in 2025. And they frame obesity in a way that is honestly kind of disturbing. They suggest obesity might essentially be an infectious-like state caused by something called dysbiosis.
Dysbiosis just means a microbial imbalance, but the implications are profound. We used to think of fat tissue as just inert storage, like a backpack where you stuff extra energy.
Right, a pantry.
A pantry. Now we know the gut bacteria are the ones who decide how much energy you even extract from your food in the first place, and they send signals that tell your body how to store it.
So let's introduce the main players. We have the firmicutes and the bacteroidates. These sound like warring factions in a fantasy novel.
They essentially are. They're the two biggest families, the phyla in the gut. Classically, firmicutes were known as the efficient energy harvesters.
What does that mean, efficient?
They are just really, really good at breaking down complex carbohydrates and fibers that our own bodies can't digest and turning them into calories that we can absorb. Bacteroidates, on the other hand, are generally less efficient at this.
So if I have a gut full of firmicutes, I'm literally getting more calories out of an apple than someone with a gut full of bacteroidates.
In theory, yes. Early studies in the 2000s showed that obese individuals had a much higher ratio of firmicutes to bacteroidates. It looked like a smoking gun.
It seemed too simple.
It was, and this is why we have to read the 2025 updates. The more recent data shows it's much more nuanced. That FB ratio varies heavily by geography, by genetics, by diet. The MDPI source points out that in Eastern populations, the ratio looks very different than in Western populations. So it's not just a simple good bug, bad bug seesaw.
But there is one bug that seems to be universally hailed as a hero. A guardian. Akkermansia mucinifera.
Akkermansia. I love this bacterium. It's a true specialist. It has a very specific job. It lives in the mucus layer of your intestines.
The mucus layer. That sounds kind of gross. but I'm guessing it's incredibly important.
It is absolutely vital. Think of the mucus layer as the castle wall protecting your body, your immune system, from the trillions of bacteria living just on the other side. Your gut lining itself is only one cell thick, one cell.
That's it. One cell is all that separates me from everything in there.
That's it. So that mucus layer is the barrier, it's the moat, it's everything.
And Akkermansia, it eats this wall. That sounds bad.
It sounds counterintuitive, right? But it eats the old, spent mucus, which in turn stimulates the specialized cells in your gut, the goblet cells, to produce new, fresh, thick mucus.
Ah, so it's like a constant renovation crew. It's cleaning the old stuff off so the body builds a stronger wall.
Exactly. It keeps the wall thick and robust. It's the maintenance crew for the castle wall. And its presence in the gut correlates very strongly with leanness, with better insulin sensitivity, and overall metabolic health. When Akkermansia is missing, the wall crumbles.
And this leads us directly to the leaky gut mechanism. Now, hold on. I see leaky gut on social media all the time, usually followed by someone trying to sell me a greens powder bone broth. It feels like pseudoscience. Is this a real clinical thing?
The term has definitely been co-opted by marketing, but the biological reality behind it is very stark and very real. The scientific term is increased intestinal permeability. The Medball open source goes into granular detail on the chain reaction here.
Okay, walk us through the mechanism. How does the castle wall start to leak?
It starts with a high-fat diet, or more accurately, a low-fiber, highly processed diet. When you don't feed your good bacteria the fiber they need, they starve,
Especially Akkermansia.
especially the fiber-fermenting good guys. And when they starve, they stop producing beneficial compounds called short-chain fatty acids, or SCFAs. The most important one here is butyrate.
Butyrate. We need to remember that name. Why is it so important?
Butyrate is the primary fuel source for the cells lining your colon. It's their food. Without a steady supply of butyrate, those intestinal cells get weak and sick.
They're starving, too.
They are. And when they get weak, the tight junctions, you can think of them as the rivets or the cement holding the bricks of your gut wall together, they start to loosen. The mortar cracks.
And then things can get through.
And then something very dangerous happens. A component from the cell walls of certain bacteria, called lipopolysaccharides, or LPS, begins to leak through those gaps into your bloodstream.
What is LPS?
It's also known as an endotoxin. Inside the gut, where it belongs, it's harmless. But in the bloodstream, it is a potent toxin. Your immune system sees it as a sign of a massive bacterial invasion.
So the bacteria are essentially shedding their skin, and that toxic skin is leaking into my blood.
Effectively, yes. And your immune system hates it. When LPS hits the blood, your immune system screams infection and goes on high alert. It activates a specific receptor called toll-like receptor 4, or TLR4.
And TLR4 is like the big red alarm button.
It's the panic button. Activating it triggers a massive release of inflammatory molecules, cytokines, all over your body.
So my body thinks it has a blood infection 24/7.
Exactly. It enters a state the literature calls metabolic endotoxemia. It's not a raging, acute infection that would put you in the hospital. It's a chronic, smoldering, low-grade inflammation that permeates your entire body.
And here's the critical connection to weight, right?
Yeah.
The source says this inflammation causes insulin resistance.
This is the absolute core of the whole thing. When your cells are inflamed, they go into a defensive mode. They don't want to take in more energy when they think they're under attack, so they stop listening to the signal from insulin.
They become resistant to it.
Right. So your pancreas, trying to get the message through, has to pump out more and more insulin to compensate. And chronically high insulin levels are a one-way street. It's the body's primary fat storage hormone. It tells the body, store fat, and don't burn the fat you already have.
So the obesity isn't just causing inflammation, which we've known for a while. The gut-derived inflammation is actually a primary driver of the insulin resistance that leads to obesity.
It is a vicious, self-perpetuating cycle. And it gets even worse. The sources all mention the brain connection, the gut-brain axis.
Right. Those SCFAs, that butyrate we mentioned, it doesn't just feed the gut cells.
No, butyrate can cross the blood-brain barrier. It has powerful anti-anxiety and neuroprotective effects. It's a calming signal from your gut to your brain.
And when you have dysbiosis and a leaky gut.
You lose that calming signal. The inflammation from the LPS also directly inflames the brain. This is why we see such an incredibly strong link between obesity and mental health issues like depression and anxiety. Your gut is literally stressing your brain out.
And when you're stressed, what do you crave?
Not broccoli. You crave comfort food. Sugar. Fat.
Which feeds the bad bacteria. which worsens the leak, which increases the inflammation, and the cycle just accelerates.
It's a perfect storm.
Okay, so we have a broken clock, and we have a leaking, inflamed engine with a crumbling wall. Now let's talk about the fuel we are putting into this broken machine. Section 3, ultra-processed foods.
The UPFs.
We have this massive series from The Lancet, November 2025, and they do not mince words. They define UPFs using something called the NOVA classification.
Yeah.
But let's be specific for people listening. What distinguishes a UPF from just processed food? I mean, cheese is processed, bread is processed. Are they the enemy?
That's the key distinction. Traditional processed food involves simple modifications: heating, churning, fermenting, canning, things you could do in your own kitchen. Ultra-processed food is different. It's an industrial formulation.
A formulation?
Yes, it's not really food anymore in the traditional sense. It's formulations of cheap, refined ingredients, starches, oils, sugars, protein isolates, plus a whole host of additives, flavors, non-sugar sweeteners, emulsifiers, thickeners.
And the goal isn't just preservation.
The goal is to create a product that is extremely durable, intensely convenient, and most importantly, hyper-palatable.
Hyperpalatability. That means it tastes too good to stop eating.
It's engineered to bypass your body's natural satiety signals. The source discusses energy density and texture. These foods are often soft, easy to chew, and packed with calories in a small volume. You can consume 500 calories of a UPF in 2 minutes, long before your stomach has even had time to send the "I'm getting full" signal to your brain.
It's a hack of our evolutionary biology. We evolved to seek out calorie-dense food because it was rare and valuable for survival. Now it's everywhere, and it's hijacking that system.
Exactly. And it's not just about what they are adding to these foods, it's what they are taking away. The authors call it nutrient displacement.
Meaning it pushes out real food.
It pushes out fiber-rich whole foods. And connecting this back to our previous section, low fiber equals starved gut bacteria. Starved gut bacteria equals no butyrate. No butyrate equals a leaky gut.
It's all connected. The fuel is directly breaking the engine.
It is. And the Lancet series makes a very strong and somewhat political point that this isn't just about individual willpower or making bad choices.
This is where they get into the corporate food regime.
They do. And we should be clear, we're reporting on the argument as it is presented in the Lancet. They use that term, corporate food regime, to describe a system that they argue prioritizes profit over public health.
And they mentioned something called corporate political activity, or CPA.
Yes. This refers to lobbying. The source details how, in their analysis, large food corporations actively lobby to prevent public health policies like sugar taxes or front-of-package warning labels. They argue the goal is to shape the food environment to make UPFs the cheapest, easiest, and default option.
Okay, but let's get back to the hard science of it. There was one specific detail in the PMC source about UPFs that blew my mind. The concept of acellular carbohydrates.
This is a fascinating and crucial concept. Think about a whole chickpea or a kernel of corn. In that whole food, the starch and sugar are trapped inside rigid plant cell walls.
Okay, they're in a little fibrous jail cell.
A perfect analogy. When you eat it, your digestive system has to work hard. Enzymes have to break down those cell walls to get to the energy inside. It's a slow, gradual release of sugar. The food has to travel far down your intestine to be fully digested.
It's like a time-release capsule of energy.
Exactly. But in UPFs, the industrial processing, the high-pressure extrusion, the fine milling, the puffing has already obliterated those cell walls. The carbohydrates are acellular, they are free, they're naked.
They're not in jail anymore.
They're not. So when you eat them, they are absorbed almost instantly in the upper part of your small intestine.
It hits your bloodstream like an injection of sugar.
Yes. You get a massive blood sugar spike and a massive insulin spike in response.
Huh.
But crucially, because all that energy is absorbed so early on, what's left for the bacteria living further down the line in your colon?
Nothing.
Nothing. We are systematically starving our lower gut microbiome. The good guys in the colon never get their lunch because the UPF was fully digested and absorbed 20 feet upstream.
So we are simultaneously flooding our blood with sugar while starving our gut guardians.
Precisely. And that's not all. Many of those additives, the emulsifiers in UPFs, things like carboxymethylcellulose or polysorbate 80, the research shows they act like detergents in the gut.
Detergents, like soap.
Yes. They can strip away that protective mucus layer we talked about earlier, the one Akkermansia works so hard to maintain. So UPFs are a triple threat. They're hyperpalatable, they starve the good bacteria, and they directly damage the gut lining.
This is a perfect storm. Okay, so we have the clock, the bugs, and the fuel. But now we get to the part that explains why it is so heartbreakingly hard to fix this. Why diets fail in the long run. Section 4. Epigenetics and the memory of fat.
This is the ghost in the machine, the reason the past haunts our metabolism.
The PMC review on epigenetics explains that while our DNA itself, the sequence of A's, T's, C's, and G's doesn't change, the expression of our genes does. It's like a dimmer switch, right?
A dimmer switch is a great way to put it. Think of your DNA as a giant cookbook. You can't rewrite the recipes. But epigenetics is like putting sticky notes on pages, or using a highlighter, or even clipping certain pages together so the chef can't read them.
And what's writing these notes?
The environment, your diet, your stress levels, your sleep patterns, your exposure to toxins, they control these epigenetic marks. The most common ones are DNA methylation and histone modification. They can add a chemical tag to a gene and turn it off, or remove a tag and turn it on.
And the most terrifying part of this source is the idea that fat tissue itself has a memory. What does that mean?
It means that your fat cells, your adipocytes, remember being obese. Even after you lose weight, say you go on a diet and lose 30 pounds, the epigenetic markers on the genes inside those fat cells remain altered. They retain the memory of the obese state.
So the cell is technically smaller, but it's still acting and thinking like an obese cell.
It is primed to return to that state. The review mentions a study on mice that's just chilling. They fed mice a high-fat diet, made them obese, and then switched them back to a normal, healthy diet.
And they lost weight.
They lost the weight. They looked like normal, healthy mice.
Yeah.
But when the scientists looked at the gene expression in their fat cells, it was still programmed for obesity. The epigenetic marks were still there.
And what happened when they were re-exposed to bad food?
As soon as they were reintroduced to the high-calorie food, they regained all the weight and more, much, much faster than mice who had never been obese in the first place.
The yo-yo effect. It's not just in your head, it's literally written onto your genes as a kind of metabolic scar tissue.
It is. And this brings us back to that concept of allostasis. This is that crucial shift in thinking. For a century, we've talked about homeostasis.
The body's desire to stay in balance, to stay the same.
Right. Homeostasis says, my normal temperature is 98.6 degrees, so if I get hot, I'll sweat to cool down and get back to normal. It's reactive.
Okay, so how is allostasis different?
Allostasis is predictive. It means maintaining stability through change. The body tries to anticipate future needs and adapts its baseline to meet them.
So the body thinks the obesity is a solution to a problem. It's an adaptation.
Exactly. The source calls obesity a modern disorder of regulation. Your body adapts to the constant stress, the circadian disruption, the gut inflammation, the flood of UPFs by shifting its defended set point up.
It thinks, this is a dangerous, high-energy, high-stress environment. I need to hoard energy to be safe.
Precisely. And once it establishes that new higher weight, say 200 pounds instead of 160, it defends that new weight as the new normal. It thinks dropping below that weight is a threat to survival.
This explains why the body fights back so hard when you diet. It doesn't feel like you're getting healthy. It feels like you are starving.
Yes. Your hunger hormones, like ghrelin, go through the roof. Your metabolism slows down to conserve energy. The body's doing everything in its power to save you from what it perceives as a famine.
Which is why this is relevant to the new weight loss drugs, the GLP-1 agonists like Wegovy or Ozempic. The PMC source touches on them.
It does, and they are miracle drugs for many people, no question. They work on the brain to increase feelings of satiety, but
the rebound is a huge issue.
Because of this epigenetic memory and this allostatic load, the underlying system hasn't been reset. You're just overriding the hunger signals. You take away the drug, and the body's metabolic memory takes over. It hasn't forgotten it wants to be at that higher weight. It snaps right back.
That is just heavy. It really frames obesity not as a failure of will, but as a biological trap that sets itself and is very hard to escape. But we have one more layer to add, and this is the discovery that really explains the middle age spread. Section 5.
The stem cells. The aging factor.
This comes from that science study, April 2025, a collaboration between City of Hope and UCLA. This is brand new science. They believe they have found the specific mechanism for why the waistline expands in middle age.
And it's not just the vague, your metabolism slows down. It is an active, targeted cellular process that switches on as we age. They identified a specific culprit, adipose progenitor cells, or APCs.
These are stem cells that can turn into fat cells.
Yes. In your youth, these APCs are largely dormant. They are sleeping, they just sit there in the fatty tissue, waiting for a signal. But the study found that in middle age, a specific subtype of these stem cells gets activated. They call them CPAs.
The PAs.
Committed pre-adipocytes, age-specific, the middle-aged fat makers.
Okay, so what wakes them up?
The study showed that the process of aging itself triggers a specific signaling pathway called LIFR.
The LIFR, leukemia inhibitory factor receptor. That's the key acronym here.
That is the key. When aging triggers this LIFR pathway, it's like an alarm clock going off for these sleeping CPA cells. They wake up, and what do? They start dividing and differentiating into new fat cells.
So they're making brand new fat cells.
Yes, and not just anywhere. The signaling is strongest in the visceral adipose tissue, the belly fat, the dangerous fat that surrounds your organs.
So let me get this straight. In my 20s, if I overate, my existing fat cells might just get a little bigger, like filling up a balloon.
Correct. Hypertrophy.
But in my 40s, my body is actively recruiting an army of stem cells to build entirely new fat cells, new storage units, right in my stomach.
That is what the science suggests. It's a switch from hypertrophy to hyperplasia, increasing the number of storage units, not just filling the existing ones. They did a really clever experiment where they took these older age stem cells and transplanted them into young mice.
What happened?
The young mice grew massive amounts of new fat cells. The age of the stem cell dictated the fat growth, not the age of the host mouse.
That is wild. It's like an invasion from within, triggered by your own biology.
It explains the incredible stubbornness of middle-aged belly fat. You're not just fighting your habits, you are fighting a newly activated biological mechanism, the LIFR pathway, that literally didn't exist in your body 10 years ago.
So it's not just that I'm tired or my thyroid is a bit slow. I have zombie cells waking up and actively building a fat fortress in my abdomen.
Zombie is a good word for it. It's a senescent process, a feature of aging that we are just beginning to understand and hopefully target.
Okay, I need to take a deep breath. We have covered a lot. We've got body clocks that are off, a gut that is leaking toxins into our blood, food that is engineered to starve our good bacteria, genes that remember our worst days, and now stem cells that wake up in our 40s to haunt us.
When you lay it all out like that, it sounds overwhelming. It sounds like a conspiracy against us.
It sounds incredibly depressing. I mean, seriously, is there any good news in all this research? Section 6. Can we actually fix it? Or should we just accept our fate and buy bigger pants?
There is hope, but it's not in a single magic pill. The hope lies in systemic intervention. We have to address the machine as a whole from multiple angles at once. Let's start with the gut, since that's where so much of the trouble begins. There's a lot of talk about fecal microbiota transplantation, or FMT.
The poop transplant.
The poop transplant. The MDPI review discusses this in depth. The idea is simple and elegant. Can we just take the healthy, diverse bacterial community from a lean, healthy person and put it into an obese person to fix their dysbiosis?
Does it work?
Here's the reality check. It's mixed. For certain things, like a C. difficile infection, it's a miracle cure. It works over 90% of the time. For obesity, it's much, much harder. Some studies show modest improvements in insulin sensitivity, but rarely any significant weight loss in the short term.
But why? If the bugs are the problem, shouldn't swapping them fix it?
It goes back to the ecosystem problem. You can throw new seeds into a scorched forest, but if the soil, your gut lining, your diet, your inflammation levels hasn't been fixed, the old weeds will just grow back. The recipient's old microbiome and immune system often fight back and reject the invaders.
And I imagine finding a truly lean microbiome donor is harder than it sounds.
It is. It's not just about being thin. They have to be free of all sorts of potential pathogens. It's a complex process.
So we can't just swap our bugs easily. What about taking probiotics? Just swallowing the good bugs in a capsule.
Probiotics can help. The sources mention that specific strains, like certain lactobacillus and bifidobacterium species, and even Akkermansia itself, show moderate positive effects on BMI and inflammation. But the real power, according to these 2025 reviews, is in prebiotics and symbiotics.
Okay, prebiotics are the food for the bugs we already have.
Exactly. You have to feed the good guys. This is the fiber. Inulin from chicory root, resistant starch from green bananas, or cooked and cooled potatoes. The source emphasizes that dietary fiber is the ultimate tool. It's what bifidobacterium and other butyrate producers crave.
And symbiotics is just the combination.
A combination, taking the good bugs and their favorite food together. And interestingly, the source notes that plant protein from peas or whey seems to increase the population of beneficial commensal bacteria better than animal protein from beef.
So feeding the army you have is more important than constantly hiring new mercenaries.
That's a fantastic way to put it. And then there's fixing the clock. The AHA report doesn't just point out the problem. It suggests a path forward with personalized interventions, right? This is the future. It's about understanding your personal chronotype. Are you a genetically programmed morning lark or a night owl? We need to stop giving one-size-fits-all advice.
So the goal is to tailor eating and exercise times to your internal clock, not just a generic schedule from a magazine.
Exactly. If you're a night owl, forcing you to eat breakfast at 7 a.m. might be counterproductive. Maybe your window needs to be shifted. But the most important thing, and the AHA is emphatic about this, is regularity. Consistency is what signals safety to the body.
Consistency lowers that allostatic load we talked about.
It tells the body, you don't need to hoard fat in a panic. The environment is stable and predictable.
So let's try to synthesize all of this. We are approaching the end of our deep dive, and my head is spinning with all these connections.
It really is a web. We eat ultra-processed foods,
From the Lancet study.
which act as a cellular fuel, spiking our sugar and starving our gut. This causes dysbiosis,
The MDPI review.
killing off our guardian Akkermansia and causing a leaky gut. The leaking LPS from the bacteria causes chronic inflammation. This inflammation and stress then cause epigenetic changes
From the PMC review.
that lock in the higher weight as a defense mechanism. Meanwhile, as we hit middle age, the LIFR pathway triggers dormant stem cells
The science paper.
to build a brand new fat storage facility right in our bellies. And all the while, our irregular sleep and eating schedules from social jet lag
The AHA statement.
prevents the body from ever getting a chance to rest, repair, and reset.
When you put it that way, wow, it is a conspiracy. But you said this isn't depressing. I'm still feeling a little depressed. Why is this empowering?
Because it moves the conversation away from morality and shame. For years, people struggling with their weight have been told they are lazy or weak-willed. Just eat less and move more. But this research, all of it taken together, shows that the deck is stacked biologically against us in the modern world.
Knowing the mechanic explains why the car broke down. It's not because you're a bad driver.
Exactly. And each piece of that mechanic gives you a new lever to pull. Knowing about the clock gives you the lever of light hygiene and meal timing. Knowing about the fiber needs of your gut gives you the lever of prebiotics. Knowing about epigenetic memory tells you to be patient with yourself. That weight regain isn't a failure of will, but a biological memory that takes time and consistency to overwrite.
And that middle-aged stem cell discovery, is there a lever there?
That's the frontier. The science study doesn't just identify the problem, it identifies a target, the LIFR pathway. If we can develop therapies that safely block that specific signal, we might be able to convince those stem cells to go back to sleep.
A sleeping pill for belly fat stem cells.
Potentially. But until that day comes, we have to do the manual labor of aligning our clocks, rebuilding our gut wall, and feeding our ecosystem.
Okay, I want to end with a provocative thought, something for people to chew on. The PMC source says that adipose tissue, our fat, has a memory. If our fat cells literally remember our past, our periods of obesity, can we ever truly start over? Or is the future of health not about erasing the past, but about learning to actively hack that memory?
That is the billion-dollar question, isn't it? Can we reprogram the history that's been written onto our genes? The science suggests that with enough time and with the right consistent signals, the right food, the right timing, the right movement, we can eventually rewrite that code. But we have to stop reading from the old script first.
Stop reading the old script. I love that. It's a powerful way to end.
It's a journey of reprogramming, not just restriction.
It certainly is.
Yeah.
This has been a massive, massive download. We hope your clocks are synchronized and your microbiome is happy. Thanks for taking the deep dive with us.
See you next time.